Yeah, I welcome you all for another presentation on random variables. Right? Random variables is the another important topic that we have been seeing from your probability theory and stochastic process subject. Normally, during your BTech level, we will study the subject PTSP. Okay, you have your subject PTSP in general. Okay, PTSP is nothing but probability theory and probability theory and stochastic process. So under this subject you have random variables is one of the very important chapter actually. So if you recall our previous presentations based on this random variable, we have studied a little bit information regarding what is a random variable and what is the condition for a variable that is to be a random variable, and afterwards for any random variable x or capital Y, whatever you take, you okay, for any random variable x or otherwise y or z, because I already explained you that random variable can be represented by capital letters x, y, z like that. Okay, for any random variable normally it has two types of functions. One is the probability distribution function. Okay, one is probability distribution function, and the second one is this I have already explained in your previous presentations, capital F of x. This is PDF, probability distribution function, whereas the second function is small f of x. This is what your capital PDF actually means, probability distribution function, and small f of x is nothing but small PDF, that is probability density function. Clear? This is already I explained actually. So please go through our previous presentations. There you will find the definition of probability distribution function, probability density function, and also we have explained very clearly the very important properties of probability distribution function as well as the probability density function, and even we have solved few examples in order to understand the concept of PDF and then small PDF and capital PDF, okay, in a easy way, right? So by the way, in today's presentation I would like to explain you the another important topic under this random variables is nothing but movements. This is very important topic actually. Movements of a continuous random variable or otherwise discrete random variables. The movements can be defined for a continuous random variable, or even that can be defined for even discrete random variable also. Okay, movements. What is a movement actually? What is a movement normally? Okay, what is a movement? So before going to define or to give the definition for movement, I think I have explained to that what is the expectation. Okay, just I will give you a small introduction about the expectation, the expected value of a random variable. So far, I think we have covered the density functions and the distribution function, and then the properties, and we have seen some problems, right? So before going to the movements, okay, just we will see about the expected value. Very important. Definition. Okay, expected value are also called as or average value. Clear? So the expected value or the average value of random variable x. What is the expected value? So the expected value is denoted by the, what is the first letter in expected value? E. Therefore, for any random variable x, let us say for any random variable x, the expected value can be denoted by expected of x. If you write e of x like this, then that is called as expected value of the random variable x. So your x can be, remember that x is a random variable. It is a random variable that can be either a continuous random variable or it can be a discrete random variable, right? So say for example, my x is a continuous random variable, right? If I will write here, x is a, if x is a continuous random variable, if x is a continuous random variable, then the expected value e of x can be given as, expected of x can be given as, remember this, it is given as, it is something like this, minus infinity to plus infinity, and the possible outcome value of capital X means the possible value of x is nothing but small f of x into its small pdf into dx. This is the definition. You have to remember that, because as if x is a continuous random variable, then the expected value, remember this is very important one, clear, the expected value of x, okay, for the continuous random variable x, the expected value, or otherwise if you write e of x, then this is called as the expected value, or also called as the average value of random variable x, and that can be mathematically can be given as minus infinite to plus infinite small x. What is small x? Small x is nothing but the possible outcome value of random variable x. If it is y, then you can write small y. If it is capital Z, then you write here small z. Means the possible outcome value into its probability density function. So here small x is multiplied by its small PDF. Remember that it is small PDF. It is small f of x is nothing but small PDF, probability density function, right? So this is the formula in case of a continuous random variable, right? So for a continuous random variable, the integral will be taken. The integral will be taken over the given interval. So possible outcome value multiplied by its PDF. This is the formula you should remember, right? And similarly, then if you similarly, if it is a discrete random variable, this is for continuous random variable. If it is a continuous random variable, this is the formula. Say for example, x is a discrete random variable. Then in discrete case, what you will have, exactly the same, except in integration, you will have summation only. I will write here itself. Okay. So I will write, I just replace here so that you will understand. So everything remains the same. So if x is a discrete random variable, your x is a discrete. If it is a discrete random variable, then what is the expected of x? Here x is a discrete one, then expected of x is nothing but you can write sigma. What is that? Again same, its possible value small x into probability of xi. Probability of xi, x of xi, probability of xi, where I is equal to some 1 to n, you can write anything, you can write either small n or capital N, whatever the way you can write. So this is for discrete random variable. So for discrete random variable, you will get the summation, and here the possible outcome value of the random variable x. Here x is a discrete random variable, and then this is nothing but your probability function. So in continuous random variable, here we will have small f of x, that is probability density function, whereas in discrete random variable, so for in discrete random variable, this will be given as probability function, also called as probability mass function, This is also called as probability mass function. So this is the expected value. This is the expected value. And then the second one is, and here I will give one more important definition here is that, say for example, if you can write, say for example, say this is for random variable x we are defining. So for random variable x we are defining expected of x actually, right? Say for example, if I have x power n, let us say, if my random variable is x power n, then if I write the expectation of this, it is expected of x power n, right? Expected of x power n is equal to, now tell me, if it is continuous one, it is minus infinity to plus infinity. What is x power n possible value? Small x power n into f of x into dx. So this is called as the nth moment. Here x power n is nothing but, means that what actually expected of x is nothing but the moment. This is called the moment. That is the meaning of it actually, the moment. So expected of x can also be called as the moment actually, moment, or sometimes it can be called as movement about the origin, actually. So this is called as movement about the origin. Okay, therefore if I consider the random variable as x power n, and for this x power n, if I want to consider the expected value, expected of x power n is equal to integral minus infinity to plus infinite x power n into f of x into dx. This is for a continuous random variable. This is called the nth moment of random variable x. This formula is called as the nth moment. This is called nth moment. This is called nth moment of random variable x. Say for example, where n is equal to, n starts from 1. Okay, n starts from 1. Okay, so then if you substitute for n is equal to 1, let us say, if n is equal to 1, then what you will get from that expression? This is expected of, if you substitute n power 1, I mean in place of n is equal to 1, that is nothing but simply x power 1 is nothing but e power x only. So here minus infinity to plus infinity, it is x into f of x dx into dx. Clear? So for n is equal to 1, therefore your formula becomes like this. If you substitute n equal to 1, it is nothing but expected of e power x. Here also, if n equal to 1, simply x you will have. Nothing but what? So this is nothing but the first movement. This is called the first movement. So your first movement is nothing but your mean value only, the expected value. The expected value, average value, also called as your mean value. Remember that. Mean value. What is that? Mean value. Remember. Also called as mean value. These are the three names are there for expectation of x. Okay, expected value or average value or the mean value. Therefore, remember that. So, if n is equal to 1, then this becomes expected of x only. Here, integral over, if you substitute n equal to 1, then you will have x itself, x into f of x. That is nothing but the first moment. Similarly, if n is equal to 2, let us say, for n is equal to 2, what you will have? For n is equal to 2, obviously wherever n is there, then you simply write x square, e power x square. Then you will have here integral, everything will be same, but here small x square into f of x. That is called the second moment. Similarly, if you substitute the 3 here, if in place of n, if you have 3, that is called x cube here, then it is third moment. And if substitute 4 here, and again you will get 4 here, fourth moment, fifth moment, sixth moment, and so forth, nth moment. That is what the meaning of. That's why I have started to explain about the expected value. We have started with the moment. So to know the moment, first we should know about the expectation value. It is expectation of the random variable. Okay, so that is what. Therefore, this is the nth moment, and like that, the first moment, second moment, like that. So, in sometimes in examination, they will give you that. So, they will give you, say for example, I will give one small example for you to understand about the concept of this actually. Say for example, if example f of x, I mean example, f of x is equal to, let us say, f of x equal to simply 1, let us say f of 1 is equal to 1, let us say it is for it is for it is for minus 2 to 3, it is minus 2 to 3, say for example, and this is equal to 0 elsewhere. Let us say this is the given, this is the PDF of a random variable x. So given that, you can write like this: given that the the PDF means the small PDF probability density function of random variable capital X is given as like this f of x equal to 1 for minus 1 to 2, or otherwise you can write minus 2 is less than or equal to, otherwise you can write like this: x is less than or equal to 3. Like that also you can write, no problem. And it is 0 elsewhere. Then find expected of, then find, you can, it will be given, it will be asked like this: find the expected value of x, or otherwise they will ask you that find the mean value of random variable x. Mean value, sometimes expected of x also can be asked as find the mean value, or otherwise also called as average value, right? What is the average value? These are the different names actually, right? No problem. Then how we can solve this? Sorry, how we can solve this? So I'll write the solution part. I will write the solution part. So it is a continuous random variable. So here x is a continuous random variable. So remember that for continuous random variable only you will get f of x actually. So if small f of x is given, so by simply seeing you can say that the given random variable is a continuous random variable. Or instead of f of x, if it is given p of x, then definitely the given random variable is a discrete random variable. That is the simple comparison, right? So so this is the given PDF actually of a random variable x. Then we are asking to find out expected of x. So what is the formula? You know that expected of x equal to, now what is the formula in general? It is minus infinity to plus infinity small x into f of x dx. Is it not? This is the formula actually. So in this formula, you simply substitute the limitations. This is equal to, what is the limitations? Tell me. So in between minus 2 to 3, your f of x equal to 1. Therefore, here substitute the limitations. Minus 2 to 3 means that you write minus 2 to 3, right? So you write x only, small x will come because x is the random variable. So given random variable x, therefore you are finding the mean value of x itself. Therefore you will get x as it is, as we have in the formula. X will be there. Then f of x, what is the f of x actually? So minus 2 to 3, within these limitations, what is the f of x value? It is 1. Therefore you will get here 1. Clear? So you are writing the limitations from here minus 2 to 3. In between minus 2 to 3, what is your f of x value? Your f of x value is nothing but 1. Therefore 1 you have to write. Okay, and elsewhere it is 0. Therefore elsewhere is nothing but other than these limitations. For these limitations only, this value is 1. Other than this, whatever the limitations you take, the value is 0. Therefore the function, the expectation of x value shall be calculated for this interval only. So you forget about this. Therefore into dx actually. Therefore if you simplify this integral, what you will get actually? So if you simplify this, then obviously you will get here. So let us see here. So what you will get actually? So expected of x is equal to, it is minus 2 to 3 Okay, minus 2 to 3, x into 1, it is x only, into dx. Therefore, integral of x is nothing but x square by 2. And what is the limitations? It is minus 2 to 3. Therefore, take 1 by 2 as common. Therefore, it is x square. Substitute 3 square upper limit minus what is the lower limit? Minus 2 square. Clear? So, this is equal to 1 by 2. This is equal to what is 3 square? It is 9. It is minus 2 square is nothing but 4. Right? So, 9 minus 4 is 5. 5 by 2, it is nothing but 2.5. Therefore, your expected of x value is equal to how much? It is 2.5. That is your answer. That is your answer, right? I think we'll finish off here and we'll continue in the subsequent presentation. I hope you have enjoyed this session and we will see some more examples and the continuation part of it in the next presentation. Okay, have a beautiful day.